So conversations can end here. Sharia, there is a seat available at the front for Muhaymin. We'll see. Shh. Question?
Is this the hardest part in derivative?
No, I would say this is setting us up for a harder part.
What's the hardest in it?
Well, this chapter is all about derivatives. So here we get into probably the most complex derivatives, and then we look at applying them later. And then later on, we'll look at exponential and logarithmic and trig functions and doing those derivatives. Yes? I can't remember. But often chapter 1 is a low one for people.
Right.
Yeah, because it's very different. Yep. Okay. So here we have a composition of functions, and we have a product of functions. So my question for you to briefly discuss with your neighbor is, do we start with, Gobin, you're with me? Start with the chain rule or with the product rule? Which do we think of first? Talk to your neighbor. Okay. All those in favor of product rule first. All those in favor of chain rule first. Okay. Hey, don't panic. Worry about yourself. Okay. We start with the product rule because we have these two things multiplied. And it's when we do the derivative of this second composite function that we'll do the chain rule. So product rule says we take the derivative of the first function, which is 3x squared. Oh, actually, I think the product rule as I wrote it, first function times derivative of the second. So I'm going to switch it, sorry. I'll keep the first function unchanged. Times the derivative of the second, this is where the chain rule comes in. Bring down the 6, subtract 1, keep the inside unchanged. Times the derivative of the inside, which is 4x cubed minus 5x to the 4th. So that's where the chain rule shows up. Plus second function, which is the x to the 4th minus x to the 5th all to the 6th, times the derivative of the first, which will be 3x squared. If all we were asked to do is find the derivative, we would stop there. But we're asked to put it in simplest factored form, so we'll go a little bit further. So what I would do, we don't want to expand it, because then we're going to have these huge numbers that we're trying to factor. Instead, I would look at this point and say, well, let's start with x to an exponent times a number. And here I have x to an exponent times a number. What's the greatest common factor of those two terms? Okay, so we'll factor out 3x squared. Then I'm going to look at the green brackets. And what's common for the green brackets? x to the fourth minus x to the fifth to the exponent 5. And there might be more, and there will be more, but I'm going to stop there for now because that's enough for my brain. And then I'm going to say, well, what's left over? So here, from the 6x cubed, I factored 3x squared, so I'm left with 2x. And this whole green bracketed part is gone. And so I'm left just with that red part, which is 4x cubed minus 5x to the fourth. And then from the second part, I factored out 5 of these green brackets, but I still have 1 left over. And the 3x squared was entirely factored out. So now we'll just simplify that black bracket. And on a test, this would be enough for simplest factored form. On the assignment, I'll want you to go further yet. How would we go further? So we'll just put that's good enough for a test. On an assignment, let's keep this 3x squared. But inside here, I could factor out an x to the fourth and have 1 minus x all to the fifth. And in my next bracket, I could factor out also an x to the fourth and then have 9 minus 11x. Okay, so I'll have the 3. This x to the fourth is to the fifth, right? So that's going to be an x to the 20th times x squared, which gives me x to what exponent? 22 times x to the fourth, 26. So I have x to the 26. And then 1 minus x to the fifth, and 9 minus 11x. Crazy. So assignment, I'm going to push you to this, but for a test, I'll be good with where we stopped here. Question? Okay. Yes.
Is there a question like on assignment?
Kind of. It'll take up more space. There'll be more brackets. I'll put it that way. Yes?
Go over the first question. Say why there's 3 on one side and 2 on the other.
First question?
The first part, the first step.
Oh, yeah. So if we think about this is f, and then let's say this is g of h of x. So this blue part is just my f of x function repeated. And then this part here is g prime of h of x times h prime of x. So I have Here, this 6 bracket to the exponent 5 is the derivative of the g function. Keep the inside unchanged. That's the red h function, and then times the derivative of the inside. We good? So today we're getting complex because we're combining these different rules together. Yes? Because I have a product before I have a composition of functions. So I need to start by thinking product rule. And then when I do the derivative of this bracket to the exponent 6, that's where I do the chain rule. Sorry, say that once more. No, because this part here isn't inside anything. It's being multiplied to this x cubed. So I have to think product first. Let's just scan the next few questions and talk about which function we do first. But first,
For your, you know, you start with the power rule. Why did they use like the original function and not the derivative of like the proof?
we started with the chain rule. I should say with the product rule. So we did the first function, that's the blue part, times the derivative of the second, that was the chain rule. Plus our second function, that was the composite function, times the derivative of the first function.
Isn't the product rule when you bring the exponent down, it's subtracted by 1?
That's the power rule.
Oh.
Okay. Here, what do we do first? Chain rule or quotient rule? Ask your neighbor. Okay, who would like to do chain rule first? Who would like to do quotient rule first? Oh, we have a bit of a dilemma. So, what's the outside function? Yes? Yeah, so something to the exponent 3, and then the quotient is inside, so we actually start with the chain rule. Unless we rewrote this question as x minus 2 all cubed over x plus 8 all cubed. In that case, we do the quotient rule first. But as this is, we'd want to do chain rule first. So we're going to deal with this bracket cubed first. Okay. So there's the derivative of the outside function. Keep the inside unchanged. Times the derivative of the inside function. This is where we do the quotient rule. Low. D high is 1. Minus high. D low is 1. Square the bottom. And there you go. This could be an interesting test. There's my simplest factored form. Any questions? Oh, there's always more we could do, but we'll say this is good enough for simplest factored form. Well, can we factor this anymore? Can we factor this more? Yeah, we could write the 30. Well, we can't put it in. That wouldn't be, if we put it in, it wouldn't be factoring, it would be multiplying it. We could write the 30 factored, but that's not going to be helpful. Like 2 times 3 times 5. Yeah, this is simplest. Questions on 14? Number 15? Which is first, chain rule or product rule? It will be product rule. Yes, you can try it. Thank you. So, there's one mistake that somebody corrected for me already. Any other mistakes in my work? So if you're wrong, I get to keep your ice cap? I would dump it. Yes?
I think the mistake you made is thinking that you made a mistake.
I don't think so. It's not so much that I thought I made a mistake, because if I thought I made a mistake, I would have fixed it. But it's I want to be open to the possibility that, you know what, I make mistakes sometimes. But confidence wrongly placed is not very useful. Yes?
Where would be the stopping point if this was on a test?
If I said simplify like this would be the stopping point. Yep. Quite likely for this, I would just say find the derivative, don't simplify. Because I want you to do more questions rather than spend a lot of time simplifying, because the simplifying process isn't our highest priority. We want to make sure we can find derivatives, so there'll be more questions where I just ask you find the derivative, don't simplify, and only a couple where I'll ask you to simplify. Daniel, then Rayan.
If you said only derivative, you'd stop the first step, right?
Yep. Yes. Where did that come from? When I multiply, let's go with this. So when I multiply those two radicals together, I'll just get a 4x cubed. And then times 2 times 2 times x, which would be 4x. So 4x times 4x cubed gives me the 16x to the fourth. So I knew I was running out of space, so I tried to do things in my head. Okay? Let's do another question. What rule comes first? Quotient rule, because when we do low, we keep it as it is, d high. But when you do high, d low, it's the d low part that we need the chain rule. Okay, I will give you a head start. Again, if all I said was find the derivative, we would stop here. If we're asked to simplify as we are in this case, then what I want to do is get rid of this fraction in the numerator. And this is also a fraction in the numerator because I have a negative exponent. So I need to get rid of the negative exponents. So it's really hard to see. But what I'm multiplying by here, I guess I'll write it out over top. 2 times 4x cubed minus x to the positive half. And I'm multiplying that top and bottom. And the reason for multiplying that is to get rid of all of that because all of that is a fraction. And I don't want to have a fraction inside of a fraction because then it's not in the simplest form. So I want to get rid of that. When I distribute that in, that black part, when it gets multiplied to this black box, everything just cancels out. So in this second set of things multiplied together, everything is going to cancel out, but that bracket gets multiplied to this first one also. So the fractional exponent times the fractional exponent, we actually don't have any more fractional exponents in the numerator. And then we can just expand and collect the like terms. So this would be my final answer.